Hello, this is Rick Powers coming to you from my home office for Western Technical College. And I am making a video today to talk about bootstrapping. And so I'm going to share my screen. I'm sharing my screen already. There we go. That works. So here I have for you a data set. We did a little survey during a class, and I asked how many colors are in your wardrobe. Specifically asked how many colors of socks. And I don't know if everybody was being truthful with me here, but we'll just go with these numbers. So we have people with a lot of different colors of socks. And so then when we say, okay, well, I want to understand what's going on with this, and I want to somehow come up with an estimate for my population mean for this data set. Well, I don't have 30 in my sample size, and I don't have bell-shaped data at all. And so then I look at this and I say, well, I can't then. I really can't use this. This doesn't go along with my expectations. But, and then when we look at it more closely, it seems very much skewed with a big outlier on it. And so then it's like, well, this doesn't seem like it's going to be very useful for me to be able to figure out this thing because the mean and standard deviation have been messed up by this outlier and by the skewness. So then we say, what can I do to get information about the population from this sample without setting these conditions that I normally have for bell-shaped data or n equals 30 or more or something like that. So then what I'm going to do here is I'm going to bootstrap this statistic. Now, how does that work? Well, you go to applets, resampling, bootstrap a statistic. And then we pick, of course, the column, the colors, and we could filter the data, but we're not going to. And then we say we want to do the mean. Now, down here where it says seeding for random data, this is a computer science term where the computer has to actually start by doing some number in order to create randomness. And it's a very strange computerized thing. But if we use the dynamic seed, then we're just going to get something that looks random. And if we use dynamic seed next time, it'll be different. But on your homework, you have to use a fixed seed so that you will get the same answer as what the computer did in order for you to get the correct answer on your homework, in order for it to be checked and to be correct. So the seeding here, using a fixed seed is very important for you on your homework, but we don't care right now. We're just going to use a dynamic seed. We'll just let the computer pick some number somehow. And so then we hit compute. And then what do we have here? Okay. The first thing that we have is a problem. This window is not wide enough. If you see up here, you'll see this bar, and this bar is going to be able to move back and forth. I don't want that. So I'm going to make this window wider. So now I'm not going to have this bar going across. And it's just unfortunate that StatCrunch makes that kind of thing happen. Well, then what are we actually going to do? We are going to take this data set and we're going to pretend that these are just like numbers in a hat or somewhere, and we're just going to pick them out at random, put them back in. And so we're sampling with replacement, and we're just pretending that this is a set of just numbers. And then when we do that, what we're going to find is that it will create then, we're going to do the same number of measurements here, the 12 measurements, and we're just going to pick them at random from this set. And so then what we will be creating will be an entire set of samples that aren't actually samples from data, but they are samples from this set of numbers. And it's weird, but it gives us an idea of what the population would look like. Because if we sampled from the population, certainly we would get random possibilities here. And so we're creating this pseudo distribution of samples by just picking from this sample at random. Now, let's just say that I'm going to do this 1,000 times, all right? If I do this 1,000 times, notice that I am getting something that's relatively nicely bell-shaped here. But notice also that I have a list of runs here on the left-hand side. And what's happened here is that it's done 1,000 of these different randomly generated things from 1 to 1,000. And this is where a lot of people get confused, because on the homework, it asks you for the first sample mean. What they want you to do is they want you to go over here to the left-hand side, scroll all the way up, and pick number 1, and it will give you the information about that specific mean. That was the randomly generated first sample. And so this number, 6.83 repeating, that would be the answer in your homework for the sample number 1, the mean of that very first sample. Most students don't understand that, and they think, oh, it's this number here that says mean, but it's not that number. This number is the mean of these 1,000 randomly generated samples. So on the homework, when it says find the mean of the first sample, you have to go over here and you have to scroll all the way up on the left-hand side and get that number 1. All right. Now, on the homework, it tells you a certain number of times you have to do this. We'll just do this like 5,000 times. Notice that it's kind of filling in some of these jumps back and forth, and it's just making it happen. I guess we did 6,000. On the homework, it tells you how many exactly to do. Now, then the next thing that happens is that people don't understand that the middle 95% of this randomly generated data set is the interval that we're interested in. The middle 95%, and if it's the middle 95%, then it's 2.5% on the left and 2.5% on the right. Most people, they look at this question and it says, what's the 95% confidence interval? They just look at this number, 95th percentile, but that's not what we want. We want the interval that has 2.5% on either side. And so that means we're going to have this number, 4.08 on the left, and then this number, 8.92 on the right, because the 97.5th percentile has 2.5% above it. So when it asks for the 95% interval, it's asking for these two numbers, the 2.5% and the 97.5%. So in this case, 4.08 to 8.92. So that's what we're looking at then. What is this? This is an interval then that we're using to predict where we think the population mean would be. Clearly, what we had in the original thing, and I'll just close this for a minute, what we had here originally was a mean of 6.33. And then when we do this bootstrapping, it comes out to be just about the same, 6.33. But what we're really after is, where do we think the population mean would be? And it's in this 95% interval, which is in the middle 95%. So then that would be between 4.08 and 8.92. Now we can do this for other things. We could do it for standard deviation. There's different things you can do. And in fact, if you were to take the statistics course at UWL, they would be talking about using these bootstrapping methods because we have powerful computers now and they can do this, and we don't have to have all those assumptions about the data set if we use this bootstrapping method, and it works fine in many situations. So then that would be bootstrapping for the mean. How does that compare with a standard confidence interval if we did stat t-stats, one sample with data, colors, confidence interval 95%, compute? It's different, okay? It's 3.5 to 9.2. And so then using bootstrapping gave us a little bit of a better, more accurate reading on where we think the population mean might be. And we, of course, this is not really legitimate because our sample has outliers and it has skewedness. And so the mean and standard deviation have been messed up by that. So really this t distribution is not something that we should be doing in order to make this happen. Now, let's change this to be a variable 3 here. And we'll just put in these numbers: 4, 14, 24, and 104. Okay, and so we're going to go back here and we're going to do the same resampling, bootstrap a statistic, but now we're going to pick variable 3 here. Okay, and I have my dynamic seed. I don't need to use a fixed seed. In the homework you will, but for us, we can just do this dynamic seed. So we hit compute and we start making things happen. Well, clearly this isn't going to work. This is not any kind of a bell-shaped thing. And again, if we make this bigger, certainly we can see that there are numbers involved here, but this is just a mess. There's no sensibleness to what we've created. We just have a bunch of weird little bell-shaped things. So our data set has to be somewhat well behaved, if you want to say that, in order for this bootstrapping method to work. And so we have to be careful. It doesn't work for every situation. We have to kind of try it out and see if we get bell-shaped results from the bootstrapping, then that seems to be legitimate. All right, please let me know if you have any questions.